Welcome DC Circuit students. In this demo we're going to use our solderless Protoboard and some components and our multimeter to demonstrate how to combine the resistances of resistors in series and in parallel to get an equivalent resistance. So if you're familiar with Ohm's law and the theory of how to combine resistances either in series or parallel, you'll know that the equivalent resistance of resistors that are combined in series meaning the same current flows through both resistors, you add the resistances. So your equivalent resistance is the sum of the resistance of all of your component resistors. In parallel, where there's the same voltage drop across all the resistors, but the current branches and some flows through some resistors and some through the others, we have an inverse relationship. So the total resistance, equivalent resistance, will be less than the smallest resistor. So we're going to use just two resistors to demonstrate this principle with our Protoboard. And we have a nominal 500 ohm and a nominal 1000 ohm resistor. So, and these are going to be approximate findings. So you can see this one is, our meter is telling us that it's about 976 ohms or 0.976 kilo ohms, which we could also get from our color bands. And we have 465.2 ohms for our other one, so nominal 500. So we're going to make use of our Protoboard to do some testing instead of just hooking the resistors together with our fingers, which is never good practice because you typically end up measuring the resistance of yourself. You should never use yourself as part of the circuit. That's always bad practice. So we're going to remember that sockets in a row are electrically connected and sockets that are not in a row aren't, and that all of our sockets that are adjacent to each of these colored rows are all electrically connected. So I'm going to start by connecting a couple of these rows to what's known as the power rail. So I'll connect row 56 to the red power rail, and I'll connect, and I'm using just bits of wire that have whatever color that I happen to have. These are single strand wire, and so I'll connect row 45, and if I want to connect it to the other rail. So if I need to move these to make room for the resistors, I can. Okay, so I'm going to start with a series circuit. So I'm going to connect one end of a resistor to my power rail connected row 56, and the other lead just conveniently fits into row 53. Now, since any other hole in row 53 is electrically connected, if I put a lead anywhere in row 53, it's going to be connected to the first resistor. And now I can connect this lead into row 45 and be connected out to the blue power rail, or in this case a measurement rail. I guess it's a power rail because our ohm meter has some voltage, a little source to make its own measurement. So since all of the holes in each of the rails are connected, I can give myself a couple of measurement leads to hook my multimeter to. So given that we have connected these resistors in series, we should be getting something around a little bit less than 1500 ohms. They should be additive. So we look at our ohm meter and we have 1.442 kilo ohms. So if you want to get your calculator or your pencil and paper out, you can do the math and see how accurate this is. It should be just a little bit more than the sum of the two resistors together, because we do have some resistance within our Protoboard and in our leads and the connections. So that's our series connection. So we can take this out. Now if we want to do a parallel connection, we have to think about thinking about a current flow through our measurement circuit coming in and then branching across both resistors. So in order to make sure both resistors are fed with the same current, we need them both to be in the same row to start with. So we'll put them both in the same row. And of course we're going to want the current to come out of both together, so I'm going to adjust this one. I'm going to put it back. We're going to use row 51 since that seems to be where they seem to fit best. So let's walk our way through the circuit. We have our measurement signal coming in on the red. It's going to be jumpered over to row 56 where it can supply both of these resistors. Both resistors are connected on the other side at row 51. And if I wanted to make a convenient measurement, I would connect row 51 over to the blue rail. So we should get something less than 460 something ohms if we have connected this properly. So when we hook up our ohm meter, it's going to supply a little bit of a current to give us a measurement signal. 315. So without going through the math, of our parallel circuit, parallel resistor combination, we know that this is less than the lowest resistor, so we know we got this connected correctly in parallel. In fact, if you know the values of your resistors and you are going through some mathematical calculations, you can actually use a test circuit to check your own math if you need to. Now I'm going to go over what one of the most frequent little problems that people have, that all of us have, especially if we're maybe using some dim light and we can't quite see where we've connected something. It's very easy when you're building something on a protoboard that has little holes to do something like that. If you're not right over it and you're taking a quick glance, a little parallax error, it may look like this lead is connected in row 51 when in fact it's in row 52. So if I were powering this with a power supply and then trying to do some intermediate measurements, I might get really confused because I might find that, say, I didn't get the measurement that I thought I would get. So in this case, let's see what we get from here. Oh my goodness, 465. It's almost as if I didn't have another resistor in parallel and all the current was going through one resistor. I might incorrectly infer that the rule of parallel resistor combination wasn't working. Well, what actually happened was I didn't have continuity between this lead on this resistor and the rest of the circuit. So if I wanted to see what was going on with that, I could take a look and say, okay, well, I have continuity here, and in fact it's giving me a number that corresponds to the resistance of my nominal 1K resistor. But if I come over and look to see if this end of the resistor actually is electrically continuous with the end of my circuit, I can see that it's taking kind of a convoluted path to get there, back through the other resistor. And actually I'm looking at the series path. So that would tell me that I had something connected incorrectly. So that's something to look at. It's much easier to test in a series circuit where you can just simply look for a demonstrated open. But that gave you an idea of the kinds of interesting results that you can get simply by incorrectly connecting one of my components. I turned a parallel circuit into nominally a series depending on how I measured it. So that's the biggest error, but that's easily solved by just taking a quick look and sometimes just using a pencil and just counting along the rows and then making sure that everything is where you think it is. So that's it for this quick demo of using a protoboard to build and measure a series and a parallel simple combination of resistors.